Hi everyone, welcome to the second video in our series covering how to build a sampling instrument in Max. So in the last video we patched together a very basic sample player and we discussed how to use buffers to store and play back audio files both as loops, continuous loops, and as one-shot samples. In this video we're going to look at a little bit more detail at the signal path, the way audio flows through our instrument. And we're going to go into that in a little bit more detail. So first we're going to patch up some simple mixing architecture, a way to control the signal path. And then we're going to look at creating some simple audio effects that we can use to process our signal. So before we start, you'll probably want to have your sampling instrument open that we made in the last video. You probably want to have that ready. But if you don't have access to that file at the moment, or if you just want a simpler audio player for the purpose of testing, remember that we can drag in audio files from Max's audio window on the left-hand side. We can drag and drop a sample in just to use as a kind of test or scratch track. So for instance, we could just take in a drum loop and set that to loop with the looping symbol, and that will allow us to just have some audio to test. This is useful for us because since you're working in groups for this assignment, you can't necessarily wait for one part of the patch to be finished, someone else is working on, before you can start on your sort of element of the patch. So it's useful to have temporary files so that you've always got some signal to test, so you've always got something that you can work on. So you could use this method using the just drag and drop audio files. You can also look into Max's beep modules, which on the left hand side, again, these are a series of lots of different things, and they cover kind of all different elements of Max. But for instance, you could find an audio playback something or other. You know, if you needed a mixer because someone else in your group is working on the mixer, you can find one here and drag it in and you get a little mixer module. So let's get rid of that. So for today I'm going to work with our file that we got last time, so I'm going to close that, and here is our file as we left it at the end of the last video. This is where we got to last time. A stored sample in a buffer over here that we were triggering with a bang, if you remember. So if I turn the audio engine on, you will hear that when I send this bang, it will trigger this sample, which is the test buffer, which has, at the moment, it has a vibraphone sample in it. So if I... There we go. Now, while this isn't strictly part of your assignment, it's really important when you're learning Max to try and have fun with it, and to explore new things and to make mistakes. So instead of just keeping this sample playing ad nauseum, remember we were using the metronome to send just periodic triggers. So instead of just letting that run for the rest of this session, that could get very, very boring very, very quickly. We're going to have a little fun. So if you remember how we were using this metro object as a metronome or a clock to output a periodic bang every X milliseconds. So in this case, every 1000 milliseconds, which is every second. Well, instead of doing that, how about we insert a new object? I'm going to insert a random object. Now what this does is every time the random object receives a bang or a trigger, it generates a random number between 0 and whatever the argument that we give it. So here I'm going to say between this 0 and 1000. So if I patch the bang that we get out of the metronome into the input, you'll see when I start this playing, we'll get a random number, an integer between 0 and 1000 every time, every second. So let's add some randomization to our metronome. And instead of just having it acting as a constant metronome, let's randomize the number. So what I'm going to do is I'm going to take the output of the random and I'm going to plug it into the metronome time interval of the metronome. So now what's happening is every time the metronome triggers, every time it bangs, it's going to change its own speed, creating a random clock effect. So, how could we take this further? How could we make this more interesting? Well, variety is the spice of life, so we'll vary more things. Let's add another random object, but instead of outputting a value of 0 to 1000, quite a large range, we're just going to output a smaller range. So it'll still be triggered every time the metronome sends a bang, so every time we trigger a new sample. But this time we're going to create a new integer between 1 and 10, see? And we're going to output this to the speed or the pitch of our sample. There we go, changing things up quite a bit. We're changing both the speed at which the sample is triggered and the speed at which it's played back, not at the same thing. So we'll sometimes get lots of quick samples triggered that are very slow, played slowly, played low, and sometimes we'll have longer distances between our triggered samples that are played quite high. And obviously we can change these values. So if I were to get rid of these as outputs, we could, sorry, let's get rid of that. We can change the size of our random range with another integer. So I could say, let's take much longer. This is 3 seconds effectively as the maximum limit of our sample triggering. Or we could take it right down. We could make a lot of much quicker hours of fun. Okay, so this sample that we're playing is mono. It's only one channel. So if you look at the visual meter that we set up last time, or you're listening on headphones, you'll realise that our sample is only playing on the left channel of our system. So how can we control this? If you think about a mixing desk for a moment, recall that we typically have a gain control fader, which is what we've got here. We can control the gain, the amplitude, the volume of our signal. We might have some kind of EQ to control the different sort of frequency bandwidths of our sound. And we usually have a pan control knob. Now, pan control allows us to place a signal within the stereo field, effectively fading from left to right or sitting the sound in the sort of center, so balanced across both speakers. Max lets us do this with the pan2 object. Pan2 accepts a mono signal in, and it outputs 2 channels, a left and a right channel. And then if you look at the other inlets along the top, we have pan from using a control value of -1 to 1, but we also have a MIDI pan, which takes a value of 0 as left, and right as 127, which you'll recall last time we talked about MIDI control values ranging from 0 to 127. So let's get this set up. Now, since this audio file that we're working with here is mono, all of these extra sort of parallel signal paths we're not using this time. They're useful if our sample is stereo, and in some of your assignment, some of the channels do need to be stereo, but for the mono channels we can largely get rid of them. So let's take these out just to clear some space. So this is all we're interested in here. We could also take the groove object to make it a single number of outputs, one output. And we could change the buffer, but I'm not going to replace the sampler. So for the time being, I'm just going to turn the volume down, because we don't need to listen to this while we're setting this up. So let's take this off. So now we need to take this pan2 object where we have a signal in, a mono signal in, and we get a stereo signal out, left signal out and right signal out. So let's take this here. Let's clear some space for us. Put that there. Put that there. I'll clean that up a little bit. So now when our signal is playing, we have a way of panning our signal from left to right. Now we could do that with the slider that we used before, and you'll recall that unless we modify it, the output is from 0 to 127, which is what we know this inlet takes. We could, if we wanted to stay true to the mixing console though, we could also use a dial object, which also runs from 0 to 127. So let's use that for now, just as it allows us something a little bit different to the gain control knob. And we'll take this value and put it into the third inlet of pan 2, which you'll just want to check is MIDI pan 0 equals left, 127 equals right. So now we can see that we're panning our signal. Right. So let's just get rid of this. Sorry, we'll make a copy. We want to say this is our left channel. This is our right channel. I nearly forgot, we need to attenuate the output of this, remember? For our gain channel, otherwise it's going to be very, very loud. So just put that there, clean that up. Right, so now when we turn on our audio engine, what we should get is our signal panned all the way over to the right, 127. Turn this up. There we go. And now as I pan across, you'll see the signal appearing to move across the stereo field. Now, if 0 is left and 127 is right, then what's the center? Well, 64. So a nice little thing to put in here is if we put in not a new object, but a new message, and I can use that either with the M keyboard or I can put in a message here, and if I just say 64, if we connect that to the dial here, whenever I click 64 now, our panning control will automatically pan to the center. Kind of nice. It's almost like when you use the control knob on a mixing console and you have the little inlet carved in, so it sort of, you can feel when you reach the center point. It's kind of like that. So cool, we have a pan control. Now we don't have to for the sake of the assignment, but again it's fun to make things a little bit more interesting. So if you remember our random metronome, what if we add another random value, this time outputting between a range of, you guessed it, 0 and 127. So now, once again, whenever our new sample is triggered, it also triggers a new pan position. This is a particularly nice effect if you're listening on headphones, because you just have each of these little sounds panning around. It's quite nice. Cool. So I'm I'm not going to look at EQ and filtering today. Let's turn that off, because it's not strictly part of the assignment. But if you are interested in filling out this kind of idea of the mixer channel strip, then you could look at two max objects. I'll just type them here. Biquad and Cascade, those two objects. And they'll allow you to kind of insert new filter kind of mechanisms by quad tilde. And remember, with all max objects, if you open up the help reference, you can do that by alt click. What you see is an example file of that object being used, and it's really good because you can learn how they work in context and kind of mimic or copy that way of working into your own patch and then develop upon it. So this is the example of the filter. So if I just so it's very easy. You could incorporate that in your max patch. So far, we've only been dealing with one signal path. We have one sample, and that plays back into the master output channel where we hear it. But in our sample instrument, we need to listen to a number of signals. We're going to have a number of different samples all playing back different audio files, all to a common master output. So to do that, we're going to need to create a number of instances of our playback system. Now, that's this here. So for the most part, you can just copy and paste. There we go. We have two playback systems now, and we just do that as many times as we need for different samples. Remember though that now I've just got two copies playing back the same sample. So if you're going to do this, you're going to need to change the name of the buffer each time. So for instance, you could have groove test buffer 1 and groove test buffer 2, or sample 1, sample 2, and so on. But our patches can get very messy if we just start copying and pasting large elements of the system. So let's get rid of that. And let's look at a smarter way of doing this, a little bit neater. So if I select an element of a specific function, something that we want to run, so I'm going to say, let's take this section that plays back our sample. So it goes from the point that's triggered from a bang to playing back, and we get some audio out. So if I do this, we can then encapsulate this. If we go to Edit, Encapsulate, or Command-Shift-E, what will happen is we've now taken all of that code and we've hidden it away. We've put it in what's known as a subpatcher. It's a bit like a folder where you keep a number of different files. Now we're keeping all of those elements of that patcher within this subpatcher. Let's give it a name. Let's just call it playback. And that'll help us find it later. And again, remember, you need to keep track of things. So subpatcher to play from buffer, just to tell us what's going on. And now if I want to see any of that code, we just double click, and there it is in its own little window, out of the way, kept neat. So let's say now that for the sake of argument, I'm going to say that this is going to play back at half speed, so 0.5. So let's just check that. There we go. So whenever I trigger this playback system, it's going to play at half speed. And now let's copy and paste this over here. And we'll send it to the same output. And we'll give it a different trigger. So when I open this one, we'll set it to something like 4, and we'll just need to reinitialize this load bang because we haven't opened it up fresh. So I'm just going to double click that. So now this playback object is playing back at half speed, 0.5, and this playback object is playing back the same sample, both test buffer 1, but this is playing back at 4 times the speed. So notice how they overlap. Now that's because they're actually separate groove objects, so they're all referencing the same buffer, but they're doing it separately. So that's useful because you could have multiple samples playing fragments of the same sample, but a bunch of different times. Now, you can take this method of encapsulation, you can take this further, and you can do encapsulation in encapsulation. It's useful when you come to work on the main patch, you know, encompassing all elements of this sampling instrument, because it means that you can put the fiddly bits kind of out of the way so that you're not scrolling through a massive kind of confusing max patch all the time. So it's quite a good habit to get into. So yeah, remember that the shortcut is Command, Shift, and E, and that just patches everything up. Remember to rename these files. So now we have even more. We have 3 of these things. And well, actually no, let's get rid of these, and let's put this all back in the main section. So I'm going to cut this out, get rid of this, and I'm going to copy it all back in. So we're back where we started effectively. We can get rid of this outlet, and I can plug this in here. Oh, no, inlet, don't need inlets and outlets. Inlets and outlets are what allow you to plug into and out of a subpatcher. That's what those strange objects are. If you need to create them, you can just type inlet or outlet. So now we're back where we started. So I want to take absolutely everything apart from the trigger, but including the pan. Oh dear. Let's copy everything and this. So that's everything apart from that one trigger and the master output, the easy DAC. And I'm going to encapsulate all of it. I'm going to call it sample player. Now, there we go. All of that is contained within there with an inlet, plugging it in, and an outlet. So I need to set the gain, I need to set this, and I need to reinitialize that. And I can set, I can set that to 1, so it's playing back at normal speed. So when I trigger this, there we go. Now, if we were to have, for instance, a few more of these, and they are all plugged in over here to the main output, it gets a little bit messy very quickly. And this is how you see kind of more advanced max patches where there's lots of stuff going on. This is how they look like ungodly spaghetti mess. So let's think of some ways that we can fix that. One of the nice ways is, and we don't need all these for the time being, if we go back in here, we can use messages to send elements of a max patch somewhere else without a cord linking the two. So we're basically saying, hey, take this thing, take this signal, and send it somewhere else. So what I'm going to do is I'm going to use the send tilde object, and I'm going to say left main, or maybe better, to left main. and then I'm going to create another copy, so I'm just doing it Alt and drag, and this one's going to be called to right main. So instead of sending it to an outlet, I'm going to take our two channels, our left and our right, and I'm going to send them like this. So now, somewhere else in this patch, and if we close this, you'll see that now there's no outlets on this because we don't need them. If I were to type receive tilde to left main and receive to right main, these things I can hook up to, I can use this live.gain. This is just a way that it will allow us to see the audio path. Now if I trigger this, there we go. Now there's no cable linking this to this, but it's doing it through this message, these send and these receive messages. So now we could still create a whole bunch of these different objects, sorry, each with triggers, and they will all play back if they're set up properly. Let's pan this one over to the right just so we can check it. Even though there's no whole bunch of spaghetti wires linking them together. This is a nice way of taking a complex audio path that needs to go to a lot of different things without, making things confusing with lots and lots of cables trailing everywhere. It's quite a handy way of doing it. Now, I'm not saying you have to do it, because sometimes it can get a little confusing remembering what all of the names are. Was that to left main, or was that from left main, or was that after the left effect, or something else? It can get a little convoluted, so maybe don't worry, but it's there if you find yourself creating a lot of patch cables. Using the send and receive object can be really helpful to simplify things and to make things a little neater and a little easier to keep track of. So I've cleaned up our patch a little bit. I got rid of all of those copies of the sample player, and now we've just got one sample player. We've got our trusty metronome back, and I've rebuilt the gain slider and meter that we've used before. But now that we've looked at the encapsulation a little bit more, we realise that maybe we don't need any of this. We can get rid of that. So that kind of allows us to move things around a bit, save a bit of space, keep things neat. Just clean that up. Okay, so now we're going to look at building an audio effect. We're going to start with something very simple. We're just going to build a simple delay effect. Now, I don't want to go into too much detail about how digital delay works and how Max responds to that and works with delay lines. For now, we're just going to build a very simple effect using what's known as a tap in line and a tap out line. So we need to create two objects for this. We need to create a tap in, and let's say 1000 there, and then we create a tap out line. And let's say we're going to do a 700 millisecond delay. Now, the way this works, broadly speaking, is that we take an audio signal and that comes in, and then the tap in says how much of that audio signal we're going to record and at what point we'll stop, and then the tap out allows us to tap into that delay line, tap out of that delay line, and create a little feedback loop. So we take our audio signal in, and then I'm just going to copy this because we want another copy of this for our delays. Let's just move that up there, it's a bit simpler. And we're going to send that over there. So then we connect the two. Now, if I start this playing. Now we haven't connected it up to any speakers yet, but you can see, kind of, that our left channel here is going up slightly after. So let's connect it up to our main output. and listen. Now I can turn up the gain of the delay line and we'll hear the second. You hear that? Now to make this stereo, we need to create another copy of the tap in and tap out. But one of the nice things is we could play around with this and we could set them slightly different speeds. So while the left channel is delaying at 700 milliseconds, our right channel delays at 600 milliseconds. I realise I'm doing this the wrong way around because that is your left and this is your right. There we go. So let's correct that. Around left channel, right channel. If you listen carefully, you'll hear the right delay moving slightly before the other one. But this doesn't really sound, well, I guess it sounds similar, but it doesn't sound like the kind of audio delay effect that we know and love, you know, the ones where it says, you know, echo, 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 echo. It doesn't feed back in the way that we want it to. So how do we do that in Max? Well, essentially it's as simple as taking some of our output of the delay and sending it back into the input. So each time a smaller amount gets fed back into the start of the delay and it loops. But we don't want to send the whole thing back because then we'd just get an infinite recursive thing and it would feed back and it would probably crash. So instead what we're going to do is we're going to attenuate the signal, and we've done this a couple of times now. So I'm going to say send it 0.2. So we're going to take this, I'm going to feed it into that. I'm going to do another over on for the right channel. I'm going to feed it back in. So what we'll hear is for each delay line, a tiny portion of that, 20%, is going to get fed back into the start of the delay line, and that's going to come back round. Then it's going to get fed back in, a little portion of it, and then it's going to go back round. And all of this is going to be fed out to our, let's call it effect mix. And let's rename this because we should have renamed it before. Always rename your subpatches. Main mix. So let's have a little listen, see what we get. Okay. And we can control the feedback amount. That's a floating point value, so let's control them. I can just increase the feedback. Let's make some of these delay times, let's play around with those. Let's say 200, quite a short delay. We start to get interesting rhythmic effects emerge. We get things that kind of sound a little bit more interesting than that straight up metronome clock. Interesting. And think about how you could play with this. Think about the things that we did at the start of this video when we took the random number generator and were passing that into the pan control, the speed control. Well, what if a random number generator was determining the delay speed, or it was determining the feedback amount? It's the great thing about Max. You can just try it. You can just plug things in and see what happens and manipulate things and send them elsewhere to other things. And while it all sounds quite vague, it's quite exciting, some of the things that you can create. You can create really new and weird sounds. And yeah, I think it's so you'll be surprised at some of the interesting things that you can create in Max. So let's just clean this up again. Let's encapsulate it one more time. need this anymore. We can get rid of that. So this is our delay. We should name these. This is our delay mix, and this is our feedback. Delay feedback. Great. So we have an audio effect that we have. It's working independently of our main signal. So this is still our main output. We could turn that off. We can listen to the delay line. We've got our sample player, which we know that we could create multiple instances of, and they'd all still be sent to receive left and receive right main because of this. We can pan our signal left and right. We can change the speed of things still. So here I've just taken our basic patch that we had before, and I've just created a couple more instances of it. So we've got 3 different copies of the same sample player. So it's the same sample, the vibraphone, and they're just playing at different speeds. You'll see different metronome speeds here, and each of them is playing at a different playback speed. So like half speed, quarter speed, full speed, just to create a kind of nice phasing effect. And then they're all running through these delay systems, and it creates quite a nice, rich musical tapestry, I think. And if we wanted to, we could use a random number generator to insert a little bit of variation into our max patch. Okay, thanks for watching. There's a few more videos left to come. I think in the next one we're going to cover MIDI and MIDI control. So, thanks very much.